So far, we've been focusing on sound as the main type of data within our DAW. But there's a separate kind of data that's called MIDI data, which is also very important in contemporary music production. And it's important to understand the fundamentals of MIDI if we want to really work well within a contemporary DAW. Now, MIDI is not a direct representation of sound like our digital audio is. Instead, it's more like the score that a musician would read. But instead of a musician reading it directly, some sort of synthesizer or sampler receives this data and performs it or realizes it as audio, which we can actually hear. MIDI stands for Musical Instrument Digital Interface. And it's what we call a serial protocol, in that one bit of information is sent at a time. Now, it's being sent very fast, so if we do play a chord, it can sound like it's a chord, but really one bit of information is sent at a time. And it's important to know what kind of information is sent with each MIDI message. A MIDI message includes a channel number. And there are 16 possible channels in the MIDI specification. You can think of them like TV channels, and it would allow me to play a single keyboard and access 16 different sound sources, which would be synthesizers or samplers. After the channel, the type of message is sent, and there are a variety of different types of MIDI messages. One of them is a note message, so we can have a note on message or a note off message. You might have noticed on many keyboards there are a bunch of knobs. Well, most of those send control change messages. And there's also one special knob that changes the pitch of the synthesizer or sampler patch, and that's called pitch bend. So those are the types of messages. And then there's going to be two data words, and these give us the parameters of those messages. So let's think about a note on message. I hold the key down on my keyboard, and it sends a note on message on a particular channel. Along with that is going to be one data word that tells us which note it is. Is it middle C? Is it the C above that? And then there's another message that sends the velocity. Now, velocity really is just how hard you hit the key. We just happen to call it velocity, but really it's just how hard you hit the key. Now, both data words are 7-bit numbers. And as we heard earlier, if we want to know how many values there are in a word, we take 2 to the power of the length of the word, and we get the number. So these are 7-bit words, so we get messages from 0 to 127. And you're going to see those kind of numbers all over the place. Now, a message is sent when you hold down the key. When I release the key, a second message is sent, which is a note off message. That will also include the channel and which note it is as a specific number. And it also includes a velocity, which is release velocity, how fast you let go of the key. Now, not all controllers send release velocity. Many do, kind of the more expensive ones usually. And not many synthesizer patches or sampler patches really respond to it. It'd be tough to come up with a parameter of sound that would change with how fast you release the key. But some synthesizers and samplers do respond to that. Now, it's important to know that two different messages are sent, because there are times when you're working with a DAW or with a controller that you find that a note just hangs on forever. We call it a hung note. And that's the instance where the receiving synth had received the note on message but didn't receive the note off, so it just keeps the note playing. The solution to that is just to hit all the keys on your keyboard and so it gets one of those note offs, or use some kind of MIDI panic function. And panic means to send all notes off, which will stop everything from playing. Now, there's a couple other things that are done with MIDI data. You'll find that you have sustain pedals on keyboards. Well, a sustain pedal sends a control change message. You might have a bunch of knobs on your keyboards. Those also send control change messages. In fact, anytime you want to change a parameter of a note over the course of the note, usually that will be a control change message. There's also one other important type of message, which is channel pressure. And again, some keyboards have this, some don't, but that's a measurement of how hard you're pushing down on the keyboard. So with many synthesizer patches, you can play the note and then push on the keyboard harder, and it will change the quality of the sound in some way. Now, that's an important thing to think about, in that we have this kind of consistent protocol, the MIDI message protocol, but it's really up to the receiving synthesizer or sampler on how to respond to that. And while there are some kind of standardized ways for a synthesizer and sampler to respond, like velocity controlling volume, it doesn't always have to respond that way. So one of the tricky things about MIDI is you're really not so sure when you send a MIDI message exactly how the synthesizer or sampler will respond. Sometimes it'll just ignore velocity messages. if you had pulled up a patch that was, say, an organ sound or a harpsichord, it might do nothing with velocity because those instruments themselves don't respond to how hard the key was hit. So it's just important to understand that there's a kind of sending machine, right? A track might send MIDI data somehow, and there'll be another device that receives it. And that receiving device really determines what happens with that data. Now, one thing to just also be just kind of thinking about is that everything that you define with MIDI data, that's equivalent to a score. It's instructions to a performer on how to work with that information. If you want something that's more for the engineer, that might be information that you would do, say, in the DAW itself and not send to the synthesizer. So when we talk about automation, we're going to be talking about something that's not sent in MIDI data, but is directed toward the DAW. It'll look a lot like MIDI control change messages. You'll have lines, you'll kind of draw shapes and create variations in sound. But if it's going directly to the DAW, that'll be automation. And if it's going to one of the MIDI synthesizers, that will be a control change message. Now, throughout this discussion, I've used two terms, sampler and synthesizer, kind of repeatedly. And I'd like to make just a point as to what those two things are. These are going to be our two main sound sources, synthesizers and samplers. And they function in a similar way. They receive MIDI data and they output an audio signal. How they create that audio signal is a little bit different from each other. A synthesizer will have kind of a geometric waveform or a formula for creating sound. You get your typical synthesizer sounds. It might start with a square wave or a sawtooth waveform. And we're going to talk about synthesizers in great depth later in the course. A sampler is going to play back previously recorded audio files, which makes sense, right? Sampling, we talked about, is a copy or taking a little bit of audio and using it repeatedly. Samplers are going to be great for recreating real instrument sounds. So a sampled violin, say, really they had a person that played every note on a violin one by one, recorded each one of those audio files, and then mapped it across the keyboard. So now it's an instrument that can be played, a sampled instrument that can be played across the keyboard. So they can very accurately represent real instruments, while synthesizers are great at creating synthesizer sounds, kind of not real sounds, perfect for dance and electronic types of music.